Algebra Unit 7, Lesson 6, Note 7, Multiplying and Dividing Polynomials. To find the product of a polynomial and a monomial, you can use the distributive property as well as the laws of exponents. Multiply the following polynomials and simplify. Letter A. So this is a type of problem that you're used to. You take what's on the outside of the parentheses and you distribute it. And the way you do that is by multiplication. 3 times d is 3d. 3 times negative 2 is negative 6. I can't combine those as they are not like terms. Let's look at letter C. We have negative 3x squared times the quantity of 7x squared minus x plus 4. I'm going to distribute that negative 3x squared to each term. And remember to use your laws of exponents. Negative 3 times 7 is negative 21. X squared times x squared is x to the 4th. Next term, negative 3x squared times negative x. Remember, there's an invisible 1. Negative 3 times negative 1 is positive 3. There's an exponent of 1 there, so x squared times x is x to the 3rd. Last term, negative 3x squared times 4. Negative 3 times 4 is negative 12. There are no variables with 4, so we just carry over our x squared. When you're doing this, make sure you're writing in standard form, which means your degrees are in greatest to least order. Let's take a look at F. We have a lot going on in this one. I'm going to start by distributing the 2p just to what's inside those parentheses. 2p times negative 4p squared is negative 8p to the 3rd. 2p times 5p is 10p squared. Then I will take this negative 5 and distribute it. Negative 5 times 2p squared is negative 10p squared. And negative 5 times 20 is negative 100. Got a couple like terms here. 10p squared minus 10p squared is 0, so that cancels out. And I'm left with negative 8p to the 3rd minus 100. We'll do one more together. Let's take a look at G. We're going to distribute the 3. 3 times 5y squared is 15y squared. 3 times 2y is 6y. 3 times negative 4 is negative 12. Then distributing negative y. Again, there's an invisible 1. Negative 1y times 7y squared is negative 7y to the 3rd. Negative 1y times 2y is negative 2y squared. And negative 1y times negative 3 is positive 3y. We've got 6y and 3y. We have 15y squared and negative 2y squared. The other two don't match up. Again, I want standard form. My largest degree is this one right here. So negative 7y to the 3rd. Then I'll look at the y squareds, which I have circled in green. 15y squared minus 2y squared is positive 13y squared. Then the y terms, which are boxed in blue. 6y plus 3y is 9y. And then bring down our last term of minus 12. Let's do the word problem together. The theme for a school dance is solid gold. For one decoration, Kana is covering the trapezoid-shaped piece of poster board with metallic gold paper to look like a bar of gold. If the height of the board is h inches, how much metallic paper will Kana need in square inches? This is a trapezoid. We're talking about area. The area formula for a trapezoid, area equals 1/2 height times base 1 plus base 2. The height is just h. It doesn't matter which one you name base 1 or base 2. So I'll just name h plus 1 base 1 plus base 2, which is 2h plus 4. The order of operations dictate I should do what's in the parentheses first, whatever I can at least. So 1/2 height. I have some like terms. H plus 2h is 3h. And positive 1 and positive 4 is positive 5. We're going to distribute the 1/2 h. So 1/2 h times 3h is 1.5 h squared. 1/2 h times 5 is 2.5 h. And this is in square inches. So inches squared. When dividing a polynomial by a monomial, divide each term of the polynomial by the monomial. So here's what I mean by that. Let me do a quick side note, and you don't have to write this down, just watch. If I had 1/5 plus 2/5, that would equal 3/5. Or in other words, what I did is I added the numerators and kept the denominator. Again, still equaling 3/5. So what we're given when we're dividing a polynomial by a monomial is we're given this. So what I need to do is I need to break it apart into different fractions. So I have two terms up top. I've got a binomial. I have 8a to the third and negative 4a squared. Each of them I can split apart and give the same denominator, negative 4a squared. And then simplify. 8 divided by negative 4 is negative 2. A to the third divided by a squared is a to the first. And then look at your second fraction here. Negative 4a squared divided by negative 4a squared cancels out, but it cancels to be a positive 1. I can't combine like terms. I've just divided. Let's take a look at B. This time I have three terms. 4x squared y, negative 12xy squared, and negative 4xy. I'm going to put each term over that denominator, 4xy. Four divided by 4 is 1. X squared divided by x is x. And y divided by y is 1. Next term, negative 12 divided by 4 is negative 3. X divided by x cancels. Y squared divided by y is y. Over here, negative 4 divided by 4 is negative 1. X's cancel and y's cancel. So x minus 3y minus 1. The important thing about these is to take them one step at a time. Split them up into separate terms, separate fractions, reduce each fraction, and you're good to go. Let's do one of the harder ones together. Let's take a look at letter G. We have three terms here, but they're fairly long. I have 35, r to the fourth, w to the third, k to the eighth. Then I have negative 20, r to the seventh, w, k to the sixth. And then I have a positive 10, r to the 20th, w to the 12th, k to the 9th, a to the 5th. I'm going to put each term over that denominator, 5r to the 3rd, wk to the 5th. Okay. 35 divided by 5, I'm looking at the first fraction. 35 divided by 5 is 7. R to the 4th divided by R to the 3rd is R. W to the 3rd divided by W is W squared. K to the 5th, or K to the 8th divided by K to the 5th is K to the 3rd. Second term, negative 20 divided by 5 is negative 4. R to the 7th divided by R to the 3rd is R to the 4th. W divided by W is 1. And K to the 6th divided by K to the 5th is K to the 1st. Last term, positive 10 divided by 5 is positive 2. R to the 20th divided by R to the 3rd is R to the 17th. W to the 12th divided by W to the 1st is W to the 11th. K to the 9th over K is K to the 8th. And A to the 5th, oh, actually, we have an extra A to the 5th up here. Oh, I'm noticing a mistake. Let me go back a few seconds here. My writing wasn't as clear. This should be K to the 5th. I think I confused myself. So let's go back to those K's. K to the 9th divided by K to the 5th is K to the 4th. And then I have no A term in the denominator, but it's in the numerator, so I can just bring it right down. There's nothing that is a like term, so believe it or not, that is our simplified solution. Go ahead and work on the rest on this page.